Hello, welcome back. I am Rajendra Bade, and in this video you are going to study orthographic projections to draw orthographic views from an isometric view. Basic approach you are going to study here. Now watch this three-dimensional diagram of an object. Here this object is a block bounded by many surfaces. There is a surface here. Surface always has a closed boundary. So here it is one surface. There is a surface here. There is a surface here. Remember, edge is change of surfaces. Where two surfaces meet, you get a sharp edge. So an edge is always, listen to me very carefully, an edge is always contained by two surfaces. For example, this edge, it is in this surface at top and it is also in this vertical surface. Or this edge, it is in the top surface and it is also contained by this vertical surface. Also, one more thing you should understand here. A corner of a solid body is formed by three edges. For example, this corner, where there are three edges are meeting. Check this corner. There are three edges are meeting. Check this corner. There are three edges meeting at the corner. Check this corner. There are three edges meeting at the corner. Check this corner. There are three edges meeting at the corner. Okay, so watch now this corner. There are only two edges. You can see. But there is one more edge which is hidden. So there is certainly one more edge at this corner. And this is what I'm telling you, that there are some hidden details. And to know those hidden details, really speaking, no much intelligence is required. A corner is formed by three edges. Corner of a solid body is formed by three edges. So at this corner there is third edge and that is hidden. Similarly at this corner there is third edge and that is hidden. Okay. Now there are many surfaces to this block. There is a surface here. There is a surface here. There is a triangular surface here. So some surfaces are of standard shape. Just for example, this triangle, a rectangle, a triangular surface. And some of the surfaces are not in a standard shape. But still, this object is formed by many surfaces. Now watch this three-dimensional object. Three-dimensional diagram of an object. There is one basic difference between this three-dimensional diagram and this three-dimensional diagram. Try to understand. In this case, of course, there are many surfaces involved here. But if you watch this object carefully, you will find three parts of this object. You can differentiate these three parts of the object. If you asked a carpenter to make this object, he will make, first of all, from a wooden sheet, he will make this base plate of this particular shape. Then he'll take a cylinder, he'll bore that cylinder and he'll attach this cylinder to the base plate. And then he'll take a triangular plate, he'll cut this triangular plate as per the given dimensions and he'll attach it. What is very important to know here, this object is formed by combination of certain shapes, certain parts, and you can easily identify these parts in the diagram. Watch here. This is triangular plate. Here it is a cylinder and this is the base plate. So this is how clearly here you can identify parts which are combined to form the given shape. Now let's focus on that first example. The two examples we discussed earlier, even if fundamentals remain the same, we use little different approach in drawing three-dimensional or orthographic views for example 1 and for example 2. So in this video, we are going to study what are those two little different approaches we use to draw the orthographic views of in these two examples. Now focus on first example. It is a rectangular block. No, it is a block formed by many surfaces. These are different surfaces. Now when such a body or a three-dimensional diagram is in front of you, what should be your approach? As I told you, basic approach remains the same. Now here, first thing what you are going to do is check overall length, width and height of the object. Now this is very important to understand that length of an object doesn't mean its longest dimension. Remember, length is dimension measured parallel to length axis. Now here one thing you must know, as you are familiar with at your school level, solid geometry or space geometry, where to define position of a point in space we use x-axis, y-axis, z-axis. These are the three dimensions measured along x-axis, measured along y-axis and measured along z-axis. Instead of x-axis, y-axis and z-axis, we'll consider here length axis, width axis and height axis. These three axes are perpendicular to each other. Now, first of all, you must know orientation of these three axes, length axis, width axis and height axis with reference to this diagram. Now try to understand. So these are the three axes. Along an axis, along this axis we measure either length or width. Along vertical axis, always we measure height. And along this axis, again length or width. Remember, height axis is vertical, but length axis and width axis. Out of these two axes, which is length axis and which is width axis, that is to be decided. Okay, but what I'm telling you, vertical axis is always height axis. And the other two horizontal axes, which are actually horizontal, they appear at an angle 30 degrees. So one of these two inclined axes, a length axis and the other one is width axis. Now out of these two, which is length axis and which is width axis, how to take that decision? Try to understand. In a three-dimensional object, as we have already studied in the last video, we can define 6 sides of the object: front, back, top, bottom and left, right. With reference to length, width and height axis, we can define 6 sides of the object: front side, back side, left side, right side and top side, bottom side. Okay, in this case, rather always, front side is denoted using such an arrow. What this arrow suggests you? The front side of the object. When observer watch this object in this direction, he gets front view of the object. So this is a front direction or this is front side of the object. Now listen to me very carefully. The axis parallel to length, parallel to this direction, this arrow is width axis. Remember, axis parallel to this arrow, that is width axis, and then obviously third axis is length axis. So this is how we take decision. Now you must have understood importance of this arrow. Okay. Remember once again, parallel to this arrow you have width axis and obviously the third axis is length axis. Now check all dimensions parallel to length axis. So 100 millimeters, 30 millimeters, 20 millimeters. Now check what is overall length of the object. Overall length means from left end of the object to right end of the object. This is left end and this is right end. From left end to right end, length is directly given 100 millimeters. So length of this object is 100 millimeter. Overall length of this object is 100 millimeters. Width is 70 millimeters from front end to back end. Width is 70 millimeters. So width is to be measured parallel to width axis. But before that, you must know which is width axis. You have understood how to decide orientation of width axis. Now, height. So from bottom to top. From top to bottom, that is height. So top to bottom height is 50 millimeters. So height is 50 millimeters. So remember once again, when a three-dimensional object, pictorial view or isometric view is in front of you, and if you wish to draw its orthographic views, so what you are going to do? Decide length, width and height axis. For that purpose, check the front side of the object denoted by such an arrow, and then identify overall length, width and height of the object. Once you are done with that, you start with a rectangle that gives overall length and overall height of the object. Now, in our earlier video, you have studied that front view gives length and height. Orthographic views are two-dimensional views. In front view, you get length horizontally and height vertically. So first of all, check what is overall length, what is overall height of the object, that is 50 and length is 100. Use these dimensions. Remember, in front view, width does not appear. So focus on length, height and simply complete a rectangle. So length is 100 millimeter, height is 50 millimeters. So with these dimensions, draw a rectangle. Remember, at this stage, we don't have any intention to draw edges of the object. We are not drawing edges of the object. It's just a rectangle which envelopes the front view we are going to draw. So the front view we are going to draw in this rectangle. Okay. Now after drawing this front view rectangle, draw top view rectangle. Now which two dimensions we get in the top view? The length and width. We don't get height in the top view. In the top view, top, bottom overlap. Top and bottom overlap. So height does not appear in the top view. So which two dimensions you get in the top view? Length and width. Better remember in this manner, length horizontally and width vertically. So now we have already measured length in front view. Same length to be transferred in the top view. So draw end projectors. We have drawn end projectors. That is, from right end a projector, from left end a projector. Logic behind that, what we have studied in very first lecture. That is, two views of a point lie on single projector. So these are corners of the object will be on the same projectors in the top view. So these are the end projectors and these are the end projectors for top view also. So end projectors of any object in front view and top view, they match. So remember, top view rectangle has length 100 millimeter and that is what is to be transferred, projected from front view to top view. You must not measure that length independently because that length 100 millimeter you are going to measure in the top view must have same end projectors, and that is why it's better to project it in downwards. So downwards for top view. So 100 millimeter length now is already in the top view. Now we'll have to measure width 70 millimeter, and in the top view width appears vertically. So length appears horizontally, width appears vertically. But before you draw this rectangle, for top view, that rectangle is not top view of this object, but that rectangle envelopes the top view. But if you draw, or when you draw this rectangle for top view, there must be sufficient distance between front view rectangle and top view rectangle. So leave some space, 20 millimeters. Really speaking, it is not necessary to measure exact 20 millimeters, but approximately 20 millimeters. Because this 20 millimeter is not any age of object. So this 20 millimeter distance is just enough space between front view and top view. So approximately 20 millimeter you measure and draw the rectangle that has sides 70, height 70, but really speaking it's not height. In the top view, width appears vertically and length appears horizontally. So front view rectangle and top view rectangle. Now let's draw side view. In the side view, 50 millimeter height will appear. You need not measure that 50 millimeter height independently in the side view. You must not. It is the same height. So just project that height by drawing two projectors in this manner. So height we have transferred in the side view. You are asked to draw left side view. So left side view to be drawn on the right side. Remember, we are using first angle method of projection where left side view is to be drawn on the right side of front view. So take care that there is enough space on the right side of front view to draw left side view. Okay. Now, which two dimensions you get in the side view? So remember in this manner, height vertically and length horizontally. Height vertically and not length horizontally. Width horizontally. So length does not appear in the side view. In the side view, you get height vertically and width horizontally. So this is very important to understand. I have seen many students take a lot of time to know this or understand this, and that is why they make mistakes. Or even if they understand it properly, they forget it while drawing actual diagram. So remember, in the side view, the two dimensions are height vertically and width horizontally. Since in these two diagrams, that is front view and top view, we have already measured length, height and width. All three dimensions we have already measured on our drawing paper. So now you must not measure these dimensions again in the side view. Instead, you should project it. And that is why we have projected height 50 millimeters from front view to side view. Now these two horizontal lines, this horizontal line and this horizontal line, these are called end projectors. Because these two lines are from top end of the front view and bottom end of the front view. So these are called end projectors from front view to side view. So front view to side view end projectors are horizontal. But what is very important, how to draw projectors from top view to side view. When you draw projectors from top view to side view, this width, which is 70 millimeters and width is vertical in the top view, that appears horizontal in the side view. So how to transfer or project this width in the side view so that the width which is vertical in the top view appears horizontal in the side view? There is one method. We draw a line at an angle 45 degrees. Now listen. In projections of solids, earlier topics we have studied, sections of solids or projections of lines, projections of planes. In these chapters, position of corresponding objects, if you remember, in all those problems were given with reference to HP and VP. For example, point A is 10 mm above HP, 30 mm in front of VP, etc. In such problem, it is very important to label XY line. In orthographic projections of machine parts, you need not label XY line. But still you must know that between front view and top view, there is XY line. Now you need not draw that XY line. If your college professors insists on drawing the XY line, you should you do that, but it's not necessary. We'll consider this horizontal line as XY line. What does that mean? That our object is resting on HP. So imagine this line as XY line and this vertical line as X1, Y1 line. So this point becomes intersection of XY line and X1, Y1 line. So directly from this corner of the front view, you draw a line exactly at an angle 45 degrees. And now, how to project this length 70 millimeters or how to draw projectors from top view to side view? This is how. Of course, you are familiar with this procedure in projections of solids or sections of solids to draw side view. We have used this procedure. So this is how the length 70 millimeter appears horizontal in the side view. And we have completed the side view. So side view width horizontally 70 millimeter and height vertically 50 millimeters. Once you have completed, remember, not a single line is dark. We have not drawn any single edge of the object. So let's start drawing views. Now remember and listen first of all very carefully. Concept of principal edges and principal surfaces I am going to give you. This is very, very important. Try to understand. Edges of object which are parallel to length or width or height axis, those edges are called principal edges. So for example, this edge is a principal edge because this edge is parallel to length axis. This edge is a principal edge because this edge is parallel to width axis. This edge is a principal edge because this edge is parallel to height axis. This is a principal edge. This is a principal edge. So this is very important to understand, and I think you must have understood. It's simple, of course. That is, edges which are parallel to one of the reference axes, those edges are principal edges. This edge is parallel to length axis, so this is one of the principal edge. This edge is parallel to one of the reference axis, that is actually height axis, so it is principal edge. So these are principal edges, and the edges which are not parallel to reference axis, those are non-principal edges. So watch here, this edge is non-principal edge. This edge is non-principal edge. All these three edges of the surface are non-principal edges. This triangular surface has non-principal edges. So first be sure that you have understood what is a principal edge. Its significance you will understand little while. But try to understand what is a principal edge, and you must have understood now and remember it. Okay. Now, principal surfaces. The surfaces which are parallel to the reference planes, that is, surface which is parallel to HP, surface which is parallel to VP, surface which is parallel to PP, these are principal surfaces. Now this is a principal surface. How will you come to know that this surface is parallel to HP? Remember, the discussion we are doing now is very, very important. Now listen to me very carefully. If a surface has two perpendicular principal edges, then that surface is a principal surface. So this surface has two perpendicular principal edges. Where are those two edges? So watch here. This edge is parallel to length axis and this edge is parallel to width axis. Length axis and width axis are perpendicular to each other. That means this angle, even if it doesn't appear 90 degrees, we are sure that this angle is 90 degrees actually. You know that in three-dimensional diagram, shapes get distorted, angles get distorted. So this angle is really 90 degrees. So this principal edge is parallel to length, this principal edge is parallel to width. So that means this surface has two perpendicular principal edges. So this is a principal surface. Similarly, this is a principal surface, parallel to height and parallel to width. So these two principal edges which are perpendicular to each other. Listen to me very carefully again. If a surface has two principal edges perpendicular to each other, then that is principal surface. So this is edge parallel to height and this edge of the surface is parallel to width. So this is a principal surface. This surface is principal surface. Okay, now what about this surface? Of course it is a principal surface. How come? So it has an edge parallel to length, an edge parallel to height. So this is principal surface. When a surface has two perpendicular principal edges, that is principal surface. Okay. Now, this surface is not principal surface. It has a principal edge. One more principal edge, but these are parallel principal edges. This is non-principal edge. So this surface does not have two principal edges which are perpendicular to each other. Same way, this is not a principal surface. This triangular surface is not a principal surface because this surface doesn't have two perpendicular principal edges. All these three edges of this triangular surface are non-principal edges. Now what about the smaller triangular surface? It has an edge parallel to width. It has one edge parallel to height. So two perpendicular principal edges. That means this triangular surface is again principal surface. Now principal surface is always parallel to one of the reference planes. So this surface is a parallel to HP. How do you come to know? So listen, it has two principal edges, parallel to length and parallel to width. Now which view gives you length and width? So length and width appears in the top view. That means this surface shows a true shape in the top view. It is parallel to HP. Length, width, plane, length, width, reference plane is HP. So this surface is parallel to HP and it shows true shape in the top view. Now focus on this surface. This has two principal edges, two perpendicular principal edges, parallel to height and parallel to length. So height, length, reference plane, height, length, reference plane, that is front view, VP. So in front view, in VP, this surface shows a true shape. This surface is parallel to VP. That is why it shows true shape in VP or in front view. Now once again listen. This surface has two perpendicular principal edges, that is, it is principal surface. Which are those two perpendicular principal edges? Parallel to height and parallel to width. Height, width, reference plane is PP, profile plane. Here you get height and width. So in this view, that is in the side view, this surface gives a true shape. This surface is parallel to PP. Now listen, if surface is parallel to HP, you may use a book, a thin book, keep it parallel to ground, parallel to floor, and check. In the top view, it gives its true shape, but in other two views, it appears line. So the surface which shows a true shape in a view, in other two views, it shows or it appears simply a line. So this surface, it shows true shape in the top view. Top view, that is the view in which length and width is. That is in the top view. In the top view, this surface shows true shape. That means in other two views, this surface appears line. This surface shows true shape in the front view and in other two views, this surface is line. This surface shows true shape in the side view, but in other two views, this surface appears a line. Now non-principal surface, watch here. This is non-principal surface. Because it is not parallel to any one of the reference planes. A principal surface which has two edges, two perpendicular principal edges, and this surface doesn't have two perpendicular principal edges. But this surface has at least one principal edge. This edge, excuse me, this edge is perpendicular to PP. Try to understand. This edge is a principal edge because it is parallel to length axis, and length does not appear in the side view. So this edge simply appears a point in the side view. So this surface is perpendicular to PP. Listen what I am telling you. If a surface has an edge parallel to length axis and length axis is perpendicular to PP, try to understand. Length axis is perpendicular to PP. In profile plane, you get height and width. So third axis is length, is perpendicular to PP. So length axis is perpendicular to PP. So if a surface has edge perpendicular to PP, it means that entire surface is perpendicular to profile plane. And if a surface is perpendicular to profile plane, then it appears a line in the side view. Try to understand what I am telling. It's very important. If a surface has an edge perpendicular to a reference plane. Now listen, this edge is parallel to height axis. That means perpendicular to HP. Vertical edge is perpendicular to HP. So if a surface has an edge perpendicular to HP, then it means the entire surface is perpendicular to HP and it appears a line in the top view. So this surface appears line in the top view. This is what we have discussed earlier also. So that means this surface appears line in the side view because it has an edge perpendicular to side view. Edge parallel to length. Principal edge. Focus on principal edges always. So this edge is parallel to length and length is always perpendicular to PP. So that means this surface is perpendicular to PP, profile plane. And therefore this surface will appear a line. Surface will not appear in the side view, it will appear simply a single line. So this surface is a line in the side view. But from top you will able to see this surface, or from front also you will able to see this surface. But from side you will not able to see this surface. Okay. So this surface will appear in the two views, but not in its true shape. This surface will appear in two views, front view and top view, but in the side view this surface will be a line. What about this triangular surface? So this triangular surface has not a single principal edge. That means this triangular surface will appear in all the three views as a triangle. This triangular surface will appear in all the three views. Of course, not in its true shape. Okay, since it is very first problem, we should discuss it properly so that you will be very fast in solving problems on ISO 2 orthographic views. Initially, you might find it slow or little complicated, but remember, this is all very important. When you want to study a new language, you will start with its grammar. But once you become familiar with the language, then your subconscious mind takes over that grammar part and you can speak very well. Similarly, here also, this much analysis is not always required once you have enough practice. Lekin, you must know this. Without that, it becomes difficult to increase your speed in drawing. And once you have enough practice, then subconscious mind will take over that principal edges and principal surfaces, all that. Okay, now let's start actual drawing. Now first, remember, when you draw views you should start with principal surfaces and principal edges. Now let's focus on this surface. Now this is principal surface. It has an edge parallel to height. It has an edge parallel to length. So height and length appears in the front view. So this surface shows a true shape in the front view. So we'll draw this shape in the front view. So right now we are going to draw this surface in the front view. Now when you draw this surface, now remember, this is very important. In any view, orthographic view or isometric view, when you want to construct a shape, there is proper procedure. First you should draw curved edges, then principal edges, and finally non-principal edge. So let's construct this shape. It is true shape. This shape in its true shape will appear in the front view. So let's start with curved edges. There are no curved edges. Okay. Now principal edges. So we'll draw principal edges. So this edge, which is parallel to length, and in front view length horizontal. This edge from left end to right end. So from left end to right end. This is how I have completed the edge. So this is a principal edge at the base, at bottom. Then this vertical principal edge on the left side. So on the left side at left end, vertical edge 25 mm. This is that 25 mm edge. Then this edge. It is parallel to length, that is in front view length horizontal. And this edge is 30 mm long. So 30 mm principal edge. Then vertical edge, total height is 50. It's given here. And 25 we have already measured here. So remaining edge, remaining length is 25. So this is that vertical edge, 25 mm. Eventually it will reach at the top. Then this edge, which is again a principal edge parallel to length, and it is 20 mm long. So 20 mm long principal edge. So all these principal edges we have completed. And now remember what I am telling you. Non-principal edges you are going to construct always by joining ends. We don't measure any length of non-principal edge in orthographic or isometric views. Remember, non-principal edges are to be drawn by connecting their ends. You will get ends of that edge first. So watch here, this principal edge, its right side end, that is this end, and right side bottom corner, this corner, right side bottom corner, you should join. So this is that inclined edge. So we have completed true shape of this surface. Remember these edges, and actually only these edges we have drawn here. So no intelligence is required. Just be very careful in measurements. Orientation of length has changed, and we know that in isometric view length appears at 30 degrees, and in front view length appears horizontally. So this edge simply has become horizontal. That's all. And this is a real shape, true shape of this surface that appears in the front view. Now this surface has its true shape in the front view, that is, it is parallel to VP, and therefore this surface appears a line in the top view and line in the side view. So let's draw this surface in the top view. Now this surface is the front surface, and this is front side. Front, back, right, left. Front, back, right and left. We have studied it in the first video on orthographic projections. Okay. So this surface between end projectors, whatever length of this surface from its left end of the surface to the right end of the surface, this surface we are talking about. From these two ends, you should visualize projectors. The same length of the surface will appear in the top view, and this surface is a line in the top view. So between these two end projectors, I have drawn that line, and that line is on the front. This is front side, back side. This is right side, this is left side. Remember, in the top view, top bottom overlap. But this is front side, this is back side, this is right side, and this is left side. So on front side, we have drawn that line. Now front side appears here. This is front in the side view. This is back side, this is top, and this is bottom. This surface appears line on the front. So front, this line. Now remember, the line view of this surface must be in between projectors. So highest point on the surface and lowest point on the surface. That is entire height of the surface you are going to project it here. And that is why from top end and from bottom end visualize projectors. And you will get that line on the front. So this surface is over in front view, top view and side view. Now let's focus on this surface. This is also a principal surface. Remember, first focus on principal surface. Principal surface shows true shape in one of the three views. Now this surface, because it has two perpendicular principal edges, this principal surface, this edge is parallel to length, this edge is parallel to width. So length and width view, that is top view. In the top view, this surface will show its true shape. So let's draw this surface in the top view. So when you want to draw true shape of a surface, remember, first curved edges, then principal edges, and finally non-principal edges. Now this surface has no curved edges. Okay, so now principal edges will draw. This edge is on the back side, parallel to length. So parallel to length on the back side, I have completed this edge from left end to right end, from left to right, parallel to length. Length is horizontal in the top view. Now this edge 35 millimeters. This is width. In the top view, width appears vertical. So measure from back side 35 millimeter parallel to width. So from back side 35 millimeter parallel to width I have measured. This length is 35. Now this is also principal edge parallel to width, but on the left side. So on the left side, from back parallel to width, measure 20 millimeter. Now this principal edge, we are drawing all principal edges of this surface which is at top. So this principal edge parallel to length, and the length is 30 millimeters for this edge. So measure 30 millimeters. Now this edge is parallel to width, and it is up to the front end. Okay. It is up to the front surface. So here it is. Then we'll draw this edge. This edge is 20 millimeters. There is already a dark line here. So it overlaps, that 20 millimeter distance or length of this edge overlaps with this dark line. 20 millimeters you may measure independently here, or you may draw projector. For smaller details, I prefer independent measurement. I avoid drawing projectors for smaller details. Okay, so this is that length 20 millimeters. So this end we got it. Now this all principal edges we have drawn. Now we are ready to draw this non-principal edge of this top surface. Now as I told you, we don't measure any length of this edge. Instead, non-principal edge, when you follow the procedure, that is first curved edges, then principal edges, and finally non-principal edges. If you follow this procedure, you will get ends of this non-principal edge initially, so that by joining those ends of the edge, you will able to complete the edge. Now try to understand. 20 millimeters at front parallel to length. So this is one end. And 35 millimeter parallel to width. This is another end of this edge. So join these, and this is how you have completed this edge. So this surface, remember, a surface has closed boundary. In the top view, it is showing its true shape because this surface is parallel to HP. So this surface will appear line in the front view and in the side view. This is top surface, so it will appear a line in the top. So in front view at top, between end projectors, this surface, total length of the surface is 100 millimeters. So from right end and from left end, draw projectors, and at top you draw this line. Where is this surface in the front view? If I ask you, simply show me this line. Okay. Now this surface is at top and it appears line in the side view. So simply draw end projectors from top view to side view. From top view to side view, draw end projectors means transfer width of that surface in the side view. And this is how at top you got that surface. So surface showing true shape in the top view is a line in the front view and a line in the side view. Now one more principal surface it has, this surface. Let's draw this surface. It has an edge parallel to height and an edge parallel to width. Height width view, that is side view. So this surface shows true shape in the side view. So let's draw these principal edges. 50 millimeter vertical edge and 70 millimeter horizontal edge. So 70 millimeter, it is actually width, and in the side view width appears horizontally. So 70 millimeter And on the back side, remember this is front side and this is back side. On the back side, 50 millimeter principal edge. So 70 and 50, we are done with that. Now this is one more principal edge which is 20 millimeter. So measure 20 millimeters. Now better measure 20 millimeters independently. But otherwise, this edge 20 millimeter long is common for this surface and this surface. So this edge we have already drawn here 20 millimeter long. So you can project this edge here in the side view by drawing projectors in this manner. It's your choice. But remember, for smaller details, I avoid drawing such projectors because you can measure easily here 20 millimeters. So from back at top, measure 20 millimeters, measure 20 millimeters. This edge is 20 millimeter long, parallel to width. Now we'll measure 25 millimeter on front, this is front side. From bottom vertically, so from bottom parallel to height 25 millimeter vertically you should measure. You may measure independently. And here already we have measured 25 millimeters. Remember, this edge is common for these two surfaces. Since this surface is already completed, 25 millimeter height we have already measured here. So you may project it in this manner. I'll prefer measuring 25 millimeters independently here. Okay. So we have drawn all principal edges and now this non-principal edge. So end of this parallel to width 20 millimeter, this is that edge, this end, and end of vertical edge which is 25 millimeter long, this edge 25 millimeter long, which actually coincides with the boundary edge. So this point and this point simply join. So this is how true shape of this surface appears in the side view. Now this surface appears line in other two views. Remember, when a surface shows its true shape in a view, then in other two views it appears a line. So this surface appears line in the front view. But where is that line? On the left side. So on the left side, watch here. This entire line is this surface. Height of this surface, that is 50, you should transfer by drawing end projectors. So end projectors here, end projector. So this is that surface. Why it is on the left side? So this question is absurd because three-dimensional diagram is in front of you and here you know that this surface is on the left side. Okay. Now, all the three principal surfaces we have completed. But wait, there is one more principal surface. This triangular surface. So now we'll draw this first principal surfaces you should complete. So this triangular surface. It has an edge parallel to width and an edge parallel to height. So two principal edges perpendicular to each other. Length and height. Width and height. So width and height appear in the side view. So this triangular surface will appear in the side view. So let's draw principal edges. So this vertical edge parallel to height from top and on the front side, this is front side, this is front side. So on front side parallel to height 25, there is already a dark line here. So this is that edge. And this line from front parallel to width, if you measure. So that means no extra work required here. Triangular surface already has appeared here in its true shape in the side view. Now let's draw this triangular surface in the front view. Now where is this triangular surface in the front view? So try to understand. This triangular surface appears line in the front view. And this surface is at a distance 30 millimeters from left end. This is left end of the body. So from left end at distance 30 millimeters. So from left end at distance 30 millimeters. This is that line. This is left end. From left end at distance 30 millimeters. So this is that line. This line is a triangular surface. Okay. So this triangular surface in side view true shape, in front view it is here which appears a line. This triangular surface in the top view So watch here, it's same triangular surface in the front view appears line. So of course it has same projector, end projector. So here, or independently also you can think that this triangular surface is line in the top view and it is 30 millimeter from left end. So 30 millimeter from left end, this line is that triangular surface. So now you are not confused. If I ask you where is this triangular surface in the front view, to simply show me this line, because this triangular surface has its true shape in the side view. So in front view it is a line, in top view it is a line, in corresponding in between projectors. So in this projector, in between these two projectors, this is a line. If you draw end projectors of this triangular surface, watch here, these are the end projectors. So between these end projectors you will get that line. So end projectors logic is very important to understand a relative position of different features of the object. Okay, now let's proceed for this surface. This surface is a rectangular surface which appears in the top, which appears in the front, but it doesn't appear in the side. Reason I've already told you. Check. This surface has a principal edge perpendicular to side plane, PP. This is principal edge. This edge is parallel to length, and length axis is always perpendicular to height width plane, that is side plane. Height width, that is side plane or profile plane. So length is always perpendicular to the profile plane. If a surface has edge perpendicular to PP, then that surface is perpendicular to PP. So this rectangular surface is perpendicular to PP and therefore it appears a line in the side view, and it is this line. It is that inclined surface. This is edge of that inclined surface, and that edge itself becomes the entire surface because surface is perpendicular to PP. But this surface appears in the front view and also in the top view. So how to draw this surface in the front view? To watch here. We have already this edge. This edge is parallel to length at top. So parallel to length at top. This edge is also parallel to length, but 20 millimeter from base. So from base 25 millimeters. This is that edge, 25 millimeter from base. So these two edges, because these are principal edges, we have identified here. And now by joining ends of principal edges here and here, we have completed the surface. Remember, actually no extra work is required here because these two edges are already present for top surface. This surface, we have already made this entire line dark, and for this surface we have already made this entire line dark, so that rectangular surface directly appears here. Similarly in the side view again, principal edge is first. So this principal edge, which is parallel to length, but 20 millimeters from back side. So from back 20 millimeters, this is the edge parallel to length. And on the front side, this is edge parallel to length. So by joining ends of these two edges, you will able to complete the rectangle. Do you remember that non-principal edges are to be drawn by joining ends of principal edges? Okay, so this surface is over. Now finally, this triangular surface. Try to understand. All are non-principal edges. As I told you, non-principal edges are to be drawn by joining ends of principal edges. So let's draw in the top view, this edge. But in the top view, this edge is already present because this edge is common for these two surfaces. This triangular surface and the top surface which we have already drawn. That is why this edge is present already in the top view, and this is that edge. Okay. Now, just end of this edge, that is this corner and this end, you are going to join with this corner, and the shape will get created. Now, we have done this exercise in the last video. This corner is right side bottom corner and on the front. Now top view, in top view let's identify this corner. So it is at bottom, has no significance at least for top view, because in top view, top bottom you cannot separate. But it is on the right side. This corner is on the right end. So on the right end and on the front, that is this corner. So watch here again, in the isometric view, this corner, where is it in the top view? So this corner is on the right side and on the front. So on the right side and on the front side. So this is that corner. Now join these corners with ends of this inclined edge. So here, this is how. So this triangular surface has appeared in the top view. Now this triangular surface also appears in the front view. Common edge for this surface, which we have already completed. That means this edge is already present in the front view, and this is that edge. Now join this edge with third corner. Join ends of this edge with the third corner. So we'll have to identify that third corner, this corner in the front view, and where it is. So it is extreme right, that is this corner, and at top. So right and top. So this corner. So join this corner with ends of this inclined edge. And this is how you have completed the triangular surface in the front view. Now this triangular surface in the side view, and it's very important again. Listen. In the side view, we should identify these three corners. Okay. So this corner, try to understand. It is on the right side. But for side view, right side, left side, that is insignificant. Because in side view, we cannot differentiate right side and left side. We'll check it. It is on the back side. This corner is on the back side. Where is that back side? Here. Not extreme back. So from back, parallel to width 35. So this is first of all back side. And from back side, parallel to width 35. So you measure 35 millimeters here. But try to understand, this edge is already there in the top view, because this edge is edge of this principal surface. So this edge parallel to width already we have drawn here. Watch here. So you may project this 35 millimeter distance from top view to side view. This way. So 35 millimeter this length, check the end projectors here. Or you may measure independently 35. Many students get confused how to measure this, where exactly to measure 35. How to, in the sense, where to be measured exactly in the side view. So simple. Check here from the back end. This is back side. At top, that is at top, parallel to width. Width is in this orientation. So measure 35. Or you may measure 35, or you may project 35 millimeter, which we have already measured here by drawing projectors. So this corner is present here. Now we got this corner and this corner, this corner and this corner. These three corners are to be connected. Okay. Now let's focus on this corner. Where is this corner? So first thing is, this corner is at top and on the front. So at top and on the front, whether this corner is at extreme right or extreme left or in between, you need not worry about its position along length axis, because length does not appear. So tell me whether this corner is at top or bottom. So it is at top. So that corner is at top. Whether it is on the front or back, so it is at extreme front. So at top and at front, that means this is that corner. So this edge now, which is at top, you know where it is. 35 millimeter we have measured. So from this point to this point, this entire edge is at top. So here at top, that edge is. This is that edge. Exactly. Okay. So we'll join ends of this edge with this corner, and this corner is on the front, and at bottom, on the front at bottom, that is this corner. So ends of this edge, this end to be joined with this corner, and this end to be joined with this corner. But there is already a line here. We have already joined this. Now join this part. So this triangular surface we have completed in the side view. Now there is one mistake in the diagram. And what is the mistake? Remember, and this is going to help you in all problems to identify mistakes. Remember, two visible edges do not intersect. In orthographic views, remember, and also in isometric view, of course, two visible edges do not intersect each other. This is an edge of a surface. This is an edge of another surface. These two edges appear intersecting here. Remember, two visible edges don't intersect. What does that mean? Out of these two edges, this edge and this edge, out of these two edges, one edge is hidden. Now compare position of these two edges with reference to observer. This is left side view. That means observer is watching from left. So when observer is watching from left, this edge is nearest to the observer. So that is visible. So this edge which we have drawn earlier, that is edge for this surface. This edge is visible. That means the other edge, this edge is hidden. So draw hidden line. So this line is hidden. In the side view it is hidden because observer is watching from left. So left side is visible, right side is hidden. And this edge is on the right side. So it is hidden. You never get hidden edges at boundary. But this line is not at boundary. You will have to check whether it is hidden or visible. And this edge is visible because it is nearest to the observer edge. So this is how we have completed views of the object. Now what approach we use to complete this diagram? We checked principal surfaces and principal edges. Principal surfaces and principal edges. And taking help of that, we have completed the diagram. This is what I am telling you, that is example 1 and example 2 diagrams I have already shown to you. Little different approach to be used. This is object which is a single block bounded by many surfaces. So edges and surfaces are to be identified, principal edges and principal surfaces, and the drawing is to be completed. This is how we have completed the drawing. Now listen, after completing the drawing, you should insert dimensions. All given dimensions are to be inserted. Remember, as far as possible, don't insert dimensions inside the views. Smaller dimensions must be nearer to the boundary. And boundary and dimension line, that distance must be at least 8 millimeters. Of course, you need not measure that 7 or 8 millimeters. It means just sufficient distance from the boundary. Okay. Now, how to insert dimensions? Try to understand. 30 millimeters parallel to length, this length. 20 millimeters parallel to length. This is chain dimensioning. Dimensions in series. Remember this. Dimension line is a thin line. Arrows are elongated and filled. Dimensions must be written above the dimension line, but these numbers must not touch the dimension line. Chain dimensioning. Dimensions in series must be along single line, that is collinear. So this arrow 30 millimeter long and this arrow 20 millimeters long are collinear. Okay. Now 100 millimeter length, that you can show here because top view gives you length. Front view also gives the length. So you may insert that 100 millimeter length in the front view also. So this is 100 millimeter length. Leave this space at least 8 millimeters. But you must not measure it. It's wastage of time. Leave enough space and insert the dimension 100 millimeters. Okay. Now focus on width dimension or height dimensions. Okay. 25 height. So I measured 25 height and 50. Okay. Here I told you this is chain dimensioning or dimensions in series. Here dimensions are parallel dimensioning. When you insert dimensions, lines or dimensions parallel to each other, remember smaller dimensions must be closer to the boundary of the view. Distance between boundary of the view and parallel lines must be sufficient, at least 8 millimeters. And distance between two parallel dimension lines also must be sufficient, at least 8 millimeters you can say. Okay. Now 25 height and 50 height. Any other dimensions parallel to height? No. Now let's focus on dimensions parallel to width. So overall width 70, but before that smaller dimension parallel to width, that is 20. There is dimension here 35 also, and then largest dimension 70, that is overall width of the object. Okay, so 20 millimeter. In the top view width is, in the side view also width is. So in the top view will prefer. Remember, the views in which maximum hidden details are, you should avoid that view for dimensioning. Okay, so 20 millimeters. Width appears vertical in the side view, so 20 millimeters width. Then 70 millimeter, that is overall dimension. This is parallel dimensioning. And 35 millimeter, this edge. For this edge, you can insert dimension here. In absence of side view, you can insert dimension here. Remember, as far as possible, don't insert dimensions inside in between the views. Don't insert dimensions in between the views. Earlier I told you, as far as possible, don't insert dimensions inside the views. Now I am telling you, as far as possible, don't insert dimensions in between the views. So here 30 millimeters, instead of inserting 30 millimeters here, you inserted here 35 millimeters. In absence of side view, we would have inserted 35 millimeters here. Okay, so this is how I have inserted all dimensions. Remember, you must insert dimensions, and you should insert dimensions after completing the drawing. And then, since we are using first angle method of prediction, use that symbol of first angle method of prediction. So this is how we have completed the drawing. Now let's consider this problem. Little different approach we used for this type of problem. Watch here. There is a base plate which is 20 millimeter thick. There is a triangular plate. Its thickness is not given. Thickness is not given. Now listen what I am telling you. In between two major parts, such small thin plates are used to increase strength of the part, strength of the machine part. Such plates which really does not take part, such a plate which really does not take part in functioning the machine part or in functioning of the machine, but it increases strength of the machine part. Such plates are called ribs. So we'll now refer it as a rib. So this rib has thickness, but it's not given thickness of this rib or this plate, this triangular plate. In that case, we should assume certain thickness. We should guess the thickness with reference to the other dimensions. Now watch here, it is 20 millimeter thickness of this vertical or this horizontal base plate. Thickness is 20 millimeters. I think that this thickness is nearly half of 20. So we'll take this thickness as 10 millimeters while drawing the diagram. Okay. One more thing. This is a cylinder, vertical cylinder 40 millimeters high. It is connected to the base plate. And this cylinder has a hole of diameter 30 millimeters. How deep this hole is, that is not given. We don't say that it is not given. It is given where it is. So try to understand. When depth is not mentioned, then it means it is through hole. What I mean by through hole, try to understand. This hole has opening at the other end. This is not closed at the bottom, it has opening at the other end. This is through hole. So it is not just 40 millimeters long, it is extended in this plate also, so that this hole has opening at the base of the base plate. Listen. If this hole is not a through hole, and if this hole has certain depth, then this is how that depth is mentioned in the dimension. Phi 30, that is diameter 30 and 30 deep, it means this hole is 30 millimeter deep and not a through hole. So in 40 millimeters high cylinder, this hole is bored or drilled up to 30 millimeters only. So if a hole has certain depth, it is always mentioned in this manner. But in this diagram, in this problem, nothing is mentioned about depth of the hole. So we should assume that hole a through hole. This is that cylinder. I have removed the cylinder to make you understand that this hole continues in the plate. So this is that hole in the plate also. So how different this problem? If you compare it with example 1, you must have understood. In example 1, it was single block bounded by different surfaces. So we used little different approach to complete the drawing. In this case, we will be having different approach. Okay, now let's proceed. This is front side. What we are doing now? We are identifying orientation of length, width and height. So of course height is vertical and length and width axis are at an angle 30 degrees. Obviously height is vertical axis. Now we'll have to take decision which is length axis and which is width axis. Parallel to this arrow is always width axis. Parallel to this arrow is width axis. So this axis is width axis. Remember this. So obviously third axis is length axis. Now let's check dimensions. Parallel to length first. 60 millimeter, but this is not from extreme left to extreme right. When boundary edges are curved edges, left side boundary is curved edge. Remember now when I say left side, right side, this is front side. With reference to this front side, this is back side. It is left. It is right, top and bottom. 6 sides, 6 ends of the object. Do you remember? We have studied in first video. So front, back, left, right, top and bottom. So left edge is curved edge, right edge is curved edge. When circular edges are at end, then generally distances are given between their centers. So from center of this curved edge and from center of this curved edge which has radius 35, watch here it is mentioned here, from this point. Center to center distance is 60 millimeters. So when center to center distance is given, you will have to add a radius. So 60 plus 25 on the left side and radius of this curved edge is 35. So on this side 35. So 60 plus 25 plus 35. That is length. So 60 plus 25 plus 35, that is length is 120 millimeters. Height is 20 plus 40, that is 60 millimeters. So length is 120 millimeters, height is 60 millimeters. Now what about width of the object? So width is to be measured in this direction, parallel to width. So directly width is not given, but check here, widest portion of the object is this curved edge. So its diameter will be the width of the object. 35 plus 35. Radius 35, that is diameter 70. So width is 70. So this is how we have identified length, width and height of this object. Now let's start drawing the views. As usual, like in the last problem, we'll consider 3 rectangles first. Front view rectangle, height vertical, length horizontal. Top view rectangle, length horizontal, width vertical, and in the side view width horizontal and of course height vertical. So this is how we are first construct 3 rectangles. So here it is front view rectangle. Check which side view is asked, left side view or right side view. Left side view. So left side view to be drawn. So there must be enough space on the right side to complete the left side view. In first angle method operation, we draw left side view on the right side of front view. So be careful about that. Before you start drawing this front view rectangle, be sure that there is enough space for side view here. Okay. So length 120, height 60, and the rectangle is complete. Then project 120 mm length for top view. Measure width 70 mm vertically in the top view. In the top view, width appears vertical, and complete the rectangle. Now, transfer that 60 mm height in the side view. Draw 45 degrees inclined line. These are all construction lines. And width 70 mm project in the side view as usual. So this is how you will get the rectangle between these end projectors. Height 60 and width horizontally 70, and this is side view rectangle. Once you have completed front view rectangle, top view rectangle and side view rectangle. Now a very important thing. Last problem, that is example 1, that block was not a symmetrical object, but this object is symmetrical object. Try to understand. It takes, really speaking, fraction of a second, just a glance at the diagram and you know that it is symmetrical object. Okay, but try to understand here. Bottom features and top features are not identical or same. That means there is lower side and upper side are not same. Right side and left side. So left side is curved edge, right side is also curved edge, but these edges have a different radii. So left end and right end are also not similar. But all visible features on front and back appear same. So front and back are similar. Front side and back side are similar. Like mirror images. So we know that this object is symmetrical. And what is orientation of that symmetry? Front back symmetry it is. Front side and back side. Remember, in the top view, this is front side, this is front side, and this is back side. So we'll make two parts of this rectangle by drawing axis of symmetry in this manner. So this is front side and this is back side. Two halves of this top view, front and back. And this front and back are similar. Just with a glance you should understand. And that is why this is how we have drawn axis of symmetry, which divides this top view rectangle in identical front portion and back side portion. Now inside view also, this is front side and this is back side. So front and back, two identical parts we want. So draw axis of symmetry here. So join midpoints of these two horizontal edges of the rectangle, or you can draw axis of symmetry like any other projector from top view to side view. Okay. So axis of symmetry. Axis of symmetry will not appear here because this is the right side and this is left side. Right side and left side are not same here in this object. This is top and this is bottom. Top bottom are also not similar. There is a plate at bottom. Is there any plate at top? No. So top bottom are not similar. So here this view is not symmetrical. Front and back are similar, but here front and back overlap, as I told you. You cannot differentiate front and back in the front view. This is right side, left side, not similar. So don't draw axis of symmetry in this manner. Top and bottom are not similar. So you should not draw axis of symmetry in this manner also. So there is no axis of symmetry for front view. But for top view, it is a symmetrical view. Draw that axis of symmetry, front and back, two identical portions. Front and back, two identical portions. This is axis of symmetry in the side view. So if an object is symmetrical object, it is better to draw axis of symmetry initially, just after drawing rectangles. Okay, and now we'll start drawing the views. Now here, one by one edges or surfaces, unlike last problem, you need not worry about that. We'll draw views part by part. Let's focus on the base part, base plate. Its true shape appears in the top view. So let's complete true shape of the base plate. On the left side, as I told you in the last problem, how you create a shape? First curved edges, then principal edges, and finally non-principal edges. Okay, now this is curved edge. It has radius 25 and it has center on axis of symmetry. So on axis of symmetry, from left end, this is left end, this is right end. From left end, measure 25. Draw center line, establish the center. So this is how we have located center for this curved edge, and it has radius 25. So take that radius 25 and draw the curved edge. But wait, don't draw complete circle, because this is not complete circle. It is portion of a circle of radius 25. How much portion of this circle is edge of the shape? We are not sure about that. That is why don't make this curve dark at this stage. Now let's draw this curved edge. Its radius is 35 and this curved edge is on the right side. So from right side, measure 35. Locate the center. Of course, center is on center line. Top view symmetrical. Top view is a symmetrical. We know it. So on axis of symmetry, the center is. So here is that center. So with this center and radius 35, draw an arc. Again, don't make this arc dark, because how much portion of this arc is actually edge of this shape, we don't know. Okay. Now principal edges, but this surface has no principal edge. This edge is not parallel to length axis. Similarly, this edge also is not parallel to length axis. These are inclined edges, non-principal edges. So how to draw these two edges? Now there are no principal edges. These two, now non-principal edges, that is these two edges. And check here, these two edge, this edge meets the curved edges tangentially. There is no sharp corner. There is no sharp corner where edge meets the curved edge, where the straight edge meets curved edge. No sharp corner here. That means this edge meets these two curves tangentially. So simply manage a tangent here to the curves and tangent here. Let's do that. So this is tangent to the two curves, and here also tangent to the two curves. Once you get these tangents, you know how much portion of this curve is at boundary. Make those portions dark. So this is how we have completed the shape in the top view. Which two dimensions you get in the top view? Length of this plate, that is from extreme left to extreme right of the plate, 120 millimeters. And what is width? Vertical dimension from back to front, 70. So length 120, width 70. In the top view, vertical dimension is width. So length and width of this plate appear in the top view. Height appears in the front view. So how to complete this plate? So try to understand. In a view shape, remaining two views are rectangles. Use this logic. Remember, I have told you earlier that when it is a machine part, and you want to draw views of a machine part, it is placed in first quadrant in its obvious position. What is that? Its major surfaces parallel to one of the reference planes. For example, if it is a cylinder, then we place that cylinder in such a way that its circular surface is parallel to one of the three reference planes. Circular surface, that flat circular surface of cylinder, either parallel to HP or parallel to VP or parallel to PP. Now, if surface of a cylinder, flat surface of the cylinder, circular surface of cylinder is parallel to HP, then in the top view it appears circle, remaining two views a rectangle. So many parts of a machine you will able to complete using this simple logic in a view shape, remaining two views a rectangle. Now you will understand it better. Let's focus on this plate. Which two dimensions you will get in the front view? Length of the plate, that is 120. So draw end projectors. So length we have projected. And height 20 millimeter. Height is nowhere in the top view. Height appears in the front view. So measure height 20 millimeters and complete the rectangle. That's all. Front view is over. In top view shape, to remaining two views, it's a rectangle. Now let's complete the view of this plate in the side view. We already know it is simply a rectangle. A plate, if it is say hexagonal plate, circular plate, it shows its shape in one view. Remaining views, it appears simply a strip, rectangular strip. So this shape in the top view, in front view it is a strip, rectangle. In the side view also you will get that rectangle. Which two dimensions you get in the side view? Height 20. You can measure it independently or you may draw project. So I have transferred height 20 millimeter. But as I have told you earlier, that is for smaller details, I prefer measuring independently. So you may measure 20 millimeters independently. Okay. So this is how I have transferred height 20 millimeters in the side view, and width we have already measured in the top view 70 millimeter. This plate has width. Now we are not talking about overall object. We are talking about only this plate. But this plate also has width 70 millimeters. So transfer it in the side view by drawing end projectors. So this is that side view. Make it dark. So this is how we have completed top view of the plate, front view of the plate, and side view of the plate. Now, initially develop habit, because that is the proper way to complete three views of object, or when you want to draw two views of object. Remember, construct the required views simultaneously. That's always better. Of course, once you have enough practice, if you think that complete top view first, then front view, then side view, or first front view, then top view, then side view, no problem at all. But you will find that many times it is not possible to complete front view of given machine part independently. You will have to take help of top view or side view to complete front view. So it is better always to complete the three views simultaneously. Okay. So now we'll draw the cylinder. Cylinder in top view circle, remaining two views a rectangle. Simple. We already know that. It is vertical cylinder, and that's why in the top view it appears circle. What is the radius of the cylinder? 50 millimeter. Sorry, diameter is 50 millimeter. So radius is 25. And it is along the same axis, this center. So this is that center. Vertical axis is shown in three-dimensional diagram. And this entire vertical line appears point in the top view here. So on the same line, center of this arc is. So this is the center of the arc. So use it and draw a circle of diameter 50 means radius 25. So this is the cylinder. Now project it. It is a rectangle in the front view. So horizontal dimension in the top view is length, and same length will appear in the front view. So just transfer the length of this circle, that is horizontal dimension, by drawing these two end projectors. And this is how you will get the rectangle. Height is 40 millimeters. So total height 60 millimeters we have already measured, minus 20. So automatically you will get this rectangle up to the top of the original rectangle. Okay, so this is how we have completed front view. Now remember, the view in which, listen, this is very important. View in which a cylinder appears rectangle. View in which a cylinder appears rectangle, it is very important to draw axis. So we'll draw axis. So from this center, draw projector and complete axis of the cylinder. So this is vertical axis of the cylinder. Watch here. This is vertical axis of the cylinder we have drawn here. Now let's complete cylinder in the side view also. Remember, in a view shape, that is in the top view circle, remaining two views rectangle. So height of the cylinder, which is 40 millimeter, by drawing end projectors we have transferred in the side view. Now draw end projectors from top view to side view. End projectors from top view to side view means extreme front of the cylinder, back of the cylinder. These are two ends of the cylinder, front end and back end of the cylinder, draw projectors. That is why these are called end projectors for this part, that is for cylinder. And you will get the rectangle between the end projectors. So this is cylinder in the side view. So this is how we have completed the cylinder in the side view. Check, up till now we have completed two parts of the object, base plate and cylinder. Inner view shape, remaining two views rectangle. That is the simple logic. Okay. Now this cylinder has a hole. This hole. Hole. It is circular hole. Its opening circle appears in the top view. So draw that. Radius is 15. Diameter 30 means radius 15. So use radius 15 mm. Complete the circle. It is coaxial hole. That is, axis of hole and axis of cylinder are the same. इसलिए use the same radius and complete the circle. Draw projectors. These are end projectors of the circular hole. End projectors from front view to, from top view to front view. Length we are going to transfer. So extreme right of this hole, extreme left point on the hole. You draw projectors. So this is how we have transferred the length of the hole. Remember, length doesn't mean longest dimension of the body. Length means dimension parallel to length axis. So this is length here, projected upwards. And now hole is always surrounded by material. That is why it's a hole. It is surrounded by material. So it is hidden in the front view. So draw dotted lines. And check here, these dotted lines are not just in the cylinder. Cylinder in the front view is rectangle. This rectangle of height 40 mm. But these dotted lines are not just in the cylinder. We have extended in the base plate because this hole is a through hole. It is in the base plate also. By removing this cylinder, I have already shown you that hole. So extend these dotted line up to the base of front view. Now, very important thing. In top view circle, so this hole is a rectangle in the front view. Like cylinder, it is cylindrical hole in the top view, any cylinder. Inner view circle, remaining two views rectangle. So here also this hole, in this top view it is circle. So here it is a rectangle. If I ask you, where is this hole in the front view? Don't just show me these two dotted lines. Show me this entire rectangle. Remember, like cylinder, this is cylindrical hole in the front view. These are two boundary generators. Now hole has circular edge at top, that is opening of the hole, and circular edge at bottom also, that is opening of the hole on the base. So this circular edge is here, that is hidden, and this edge coincides with the top edge of cylinder. Top edge of hole coincides with top edge of cylinder. When hidden edge coincides with visible edge, we show hidden edge. So here there is an edge of the hole also, which is coinciding with edge of the cylinder. It is there. So if I ask you where is the hole in the front view, you show me this rectangle. Okay. Similarly, draw end projectors from top view to side view and from front view to side view. These end projectors are already there. Hole, its entire height of the hole is to be transferred, and that is 40 plus 20 60. So these two projectors are end projectors, and this is our hole from top to bottom. Okay, so hole is over. Now triangular plate. Now again, in a view shape, when you say that it is triangular plate, its largest surface is triangle. That triangular shape will appear in the front view. So in front view, we'll construct this triangular shape. This edge parallel to length and in contact with the base plate. So this rectangle is base plate. So in contact with the base plate at top, parallel to length edge, this length. Now this length you need not measure. It's not given, but you need not measure also. 60 millimeter, that is center of this. That is from left end 25 millimeters this corner is. So from left end 25 millimeters we have measured. So this point we have joined with the top of the cylinder, because this triangular surface has its highest point on the top edge of the cylinder. Top edge of the cylinder is here. So this is how we have completed the triangular shape. Now remaining two views, this triangular plate appears a rectangular strip. It is a plate, so it appears thin strip. And what is thickness? We have assumed 10 millimeters. And thickness is to be measured parallel to width axis. Parallel to width. And in the top view, width is vertical. So measure width 10 millimeter. Watch here. So draw end projectors of cylinder. Not cylinder, this triangular plate. Draw end projectors of triangular plate. Right end of the triangular plate, left end of the triangular plate. From right and left end of the triangular plate, draw projectors. And in between projectors, you are going to draw top view of the triangular plate. That is the rectangular strip. So watch here, this black line here. I have measured 10 millimeters symmetrically. That is 5 millimeters above the center line, 5 millimeters below the horizontal center line. So I measured 10 millimeters, and this is how I have drawn that strip which is in contact with the cylinder. Now let's complete this triangular plate in the side view also. Triangular plate in the sense, in a view that triangular shape, remaining two views rectangular strip. So draw end projectors of this triangle, that is highest point on the triangle, lowest point on the triangle. So these two horizontal lines are end projectors of the triangular plate. And draw end projectors from top view to side view. As I have already told you, I will not prefer drawing so long projectors. Instead, 10 millimeter width of this plate. Width is vertical in the top view, appears horizontal in the side view. So you can measure 10 millimeters horizontally here independently instead of drawing this projector. So measure 10 millimeter, and between these two end projectors, this horizontal projector and this horizontal projector, between these end projectors, you complete that rectangular strip in this manner. Now watch, we have completed front view, top view and side view of the plate. Front view, top view and left side view of the plate. Now let's insert all dimensions. So we have inserted the dimensions. Try to understand. All given dimensions are to be inserted parallel to length 60 millimeter here. Now what is very important now here, something new in the in this diagram, try to understand. When it is portion of a circle, semicircle, quarter circle, or any length of arc of a circle, you should insert dimension with radius. So this circular edge has a radius 25. Now watch here, this circular edge has radius 35. This is how we insert dimensions for arcs of a circle. But when it is complete circle, you must insert its diameter. So this inner circle has diameter 30 millimeters. This outer circle, that is boundary of cylinder, has a diameter 50 millimeters. So remember what I told you. Portion of a circle always to be dimensioned with radius, and a full circle you must always dimension with diameter. So insert all given dimensions, and finally symbol for first angle method of projection. You need not write here front view, top view, side view. Once you have drawn this symbol, it is clear that it is front view, top view and side. Also, first angle method of projection, top view appears below front view. So even if that symbol is not there, one should understand that this is top view and first angle method of projection is used. But still it's better to show, because it is practice. It is better to draw this symbol. Thank you for watching this video. We'll meet in my next video. Till then, take care. Bye bye.